Yeah, hello everyone. Today I like to show you my new Nodes capsule called Match Size. I think Houdini users already know the match size, so it's actually a very useful tool in Houdini. So I ported this tool from Houdini to Cinema 4D, so you can use it also in Cinema. The settings are pretty similar. In this video, I like to show you first how to install the asset, then show you the basic settings, then I show you the global and local setting. Then we do a little example with windows, so how to place some windows inside of a wall. And then the next we will build this stone circle that you see here. And then for the last part, we do a little scene notes tutorial, a little exercise where I show you some tips with working with matrices, and we building kind of a little world bounding box, a scene note capsule. And yeah, so I think we jump into Cinema and we start with the installation. First, you have to download the zip file, so the scene note asset from Gumroad. You find the link in the description of this video. So then we are here in Cinema, and then we open the content browser here, and then we go to Create, and then we say Import Asset. Then we select the downloaded zip file here. It's the match size version 1.32. So then we open it. And here in this window, we have to choose the database where we want to import our match size asset. So we can use the scene file, just the scene file. This is good when you want the asset just in this scene file and maybe also want to pass the file to another person. So the asset is embedded inside of the scene file. Then, of course, you can use your local database or your own database. I have here my own database. So I like to import this inside my own database. I have already imported it, but you can press OK, and then you can go here to the nodes, and then under the nodes here, under the geo modifiers, under M, you will find the match size tool. And if you like, you can use it as an here as a capsule, or of course, when we go to nodes, you go here and say match size. You can also use it here as a node. And if you are interested how it works inside, you can always open it. So you can go here and say asset and edit asset as group. And then you see it is converted to a group, and then you can go inside, and here you see how the whole asset works. Okay, let's start with the basic settings. I have here already a scene prepared here with a torus and a cylinder. So when we like to add our node capsule, maybe we like to add it here to the torus. So we can press Shift C and search for match size. I already searched here, match size. And when you hold down Shift and click the match size applies here to the torus. Okay, here we see the settings of the match size capsule. So first we have to decide if we like to match to a classic object or to a geo input. We use the classic object when we work here in the object manager, so in the classic workspace here. So geo input we use when we work inside of the nodes workspace. So, but this we use later. So let's use classic object first. Then we have to decide to which object we like to match here our torus. So we use the cylinder. And then we have here selection. We can also match to a selection of here our linked object, but this I will explain in the next chapter. And then also the transform space is global and local. We work now here in the global. I will also explain this setting in the next chapter. And then here we have all the different axes to match. So this is maybe similar to Houdini. So maybe let's activate X, and you already see we match here from the torus the direction X here from center to center. So the center of the torus will always stay in the center of our cylinder. So when we see we use the torus around, it always stays in the center of the cylinder. And when we move the cylinder, you will see the torus follows the cylinder. And then of course we can say which bound of the torus matches to the cylinder. So we say, okay, the minimal bound matches to the center. So we see here the minimum bound here of the torus matches here to the center of the cylinder, or we can match the maximum, or maybe the maximum to the minimum, and you can see it will always stay here the maximum here to the minimum, maximum to minimum. And then we have here an offset, so we can add an offset if we like. And maybe when we rotate objects around, we use the cylinder and rotate it. You can see here in the top view, they will always line up. Also the torus, we rotate this, and maybe you can see it better when you go to the match size and then show the bounding box. And now we have here a bounding box of both objects. So we see, okay, where are the bounds of those both objects? And then, yeah, we can play around here, say the minimum to the maximum, so it matches to the other side. And then, of course, we can do the same in the Y direction and also in the Z direction. So maybe let's center everything. Let's go here, activate all. We have center to center. And now we see, maybe disable the bounding box. The torus will always stay in the center of the cylinder. So when we move the cylinder around, the torus follows the cylinder. So maybe reset the coordinates. And then we can do the same here with the scaling. So when we activate the scaling, so you can see here it is uniform is checked. So it fits here to the X scale of the cylinder. So maybe transform the cylinder, and then we scale it here in X. You see it will always matches the scale, the X scale here of the cylinder. And of course we can do this also for the Y, so it matches here the Y scaling or the Z scaling here, you see here. And we can do this also. We can also uncheck uniform, and now it matches for every scaling dimension individually. So we can say match it just to the y-axis. So you see it matches just to the y-axis. And then of course you have here also some offsets. So yeah, so these are the basic settings to match one object to another. And in the next example, I like to explain here also the transform space. So let's jump into the next example. Okay, here maybe let's try to recreate this little church that I show you at the start of the video. We do a simple version. Maybe let's say, okay, we have the base here of our church is a cube, so something like this here. And then we like to have the church always at the bottom. So we can use actually an axis center for this. Geometry axis is it called. And then you can align it here to the y dimension. So it stays always at the bottom. But you can do the same also with the match size. So when we use a match size, hold down Shift. When we use a match size and when there is no object linked here, and we say, okay, the y dimension, we say the minimum goes to the center. So here it doesn't matter because it will always use, when there is no object, you'll always use the zero coordinate of the our global world axis here. So when we move the cube around here, you see it will always stay at the bottom. Okay, then maybe let's build a tower. First tower, we'll use a cylinder, move this here, make it a bit smaller, something like this here. Then also add a match size. Then we say we like to match to the cube. And then the x-axis here, like the maximum, the center here of our tube. We like to match this to the maximum here of our cube. Maybe call this base, maybe give them some nice name. Base, and then tower. And then the y, we like to maybe show everything here. The y, we like to have the minimum here of the tower also to the minimum of our base. So say minimum. Here will stay also always at the minimum of our base. And then the z here is actually also the center of our tower to the minimum of our z-axis. So the center to the minimum. And now when we adjust the base, the tower will always match here to the corner here of our base. Then let's build a roof. Let's use a cone. Also add a match size. And the cone here, maybe this is the roof. We like to match to our tower. Then we like to match in the X and Z direction. We like to match also the center. So activate those. And in the Y, we like to have the minimum to the maximum. So it stays here on top. And then also the scaling, like the scaling, we like to fit this to the X or to the Z. So it doesn't matter, not to the Y. So it gets too big. So to the X. And then, of course, the roof has a little overlap. So maybe use here 120 and also in the set 120. So, and now we have here a nice roof. Maybe make it a bit higher. So something like this. Then let's copy both. And then our second tower, we like to go in the other direction of the X direction. So let's match the center here to the minimum. Or maybe let's better here in the Z direction, this to the maximum. So the center of the second tower here to the maximum. And now when we move here our base, you can see, okay, this matches. Also when we maybe change the height and the radius here of one of the towers, the roof will always match. So, but now when we like to move the whole church, we have a problem. So first we like to move the base. You can see we can't move it in the Y direction. That's because we fitted here the Y here to the center of our world axis. So we can select everything, put it inside of a group everything. And then we can say to the base, okay, here the transform space is not the global coordinate system. We like to have a local coordinate system, and we like to have the local coordinate system of our null object here. And now you already see it moves up, and now we can move here with the null object, we can move it around. And when we like to rotate this, we have also a problem. When we start to rotate, stuff falls apart. That's because here our tower and our roof looks at the global transform space. So we have to switch also them to local and use the null object here. And now everything looks to the null object, not to our world axis. And now we can maybe also match because here our null object is a bit offsetted, maybe also match the base here to the center. Here. And now our little church here is always here at the center and at the bottom of our null object. So we can rotate it around, also scale it, of course. So yeah, that was the explanation here for the transform space. And now let's move on to the little Windows example where I like to explain the selections. Okay, here in this example, we have a wall here and a window, and inside of the wall we have those two holes. So we like to match the window inside of those two holes here. So you can see we have here a wall, and with a Boolean operator we made some holes here. And then we have two selection, hole 1 and hole 2. And here in the hole, I add this cube here. So with the mode on surface. So maybe recreate this. Now we see we have no selection. The selections are painted here in red. So when we go here to our hole selection 1, add the cube here. And then say surface, we can use a very small radius here. So it builds a procedural selection. So we have here the first selection and also here the second selection here made with those two cubes. Now we like to match here our window to the first hole here. So let's add a match size. Then say we like to match it here to our wall with holes. Then use a selection, delete the default and add here our hole 1. And then we like to match every axis here. So it's already perfect centered here around this selection. Then also the scaling, not uniform. So it fits perfect here into the into our hole here, and maybe in the set scaling here, the little bottom here of the window, maybe make a little offset. And now we have here a little offset of the bottom of our window. Okay. Then here the handle of our window, we also like to match to the window. So also add a match size. Then we like to match it to the window. And we like to match every axis. And maybe here in the Z direction here, we like to match the minimum of the handle, or the maximum, sorry, the maximum to the center, and give it a little offset here, something like this. Perfect. And now I'd like to do this for the other hole here. Let's duplicate the window, maybe call it window 2. And then we like to match not to hole 1, we like to match to hole, hole 2. And here we go. Now we can move our holes around, change the scaling, and also when we like to have a thicker wall here, can change the thickness of the wall, and everything matches perfect. And now here we have the same problem when we start to move the wall around, because everything is in global space. We have to decide here our local spaces here. So let's first make a null, maybe call this wall with windows. Put the windows and the wall with holes here inside this null. Then the windows, because they match to the wall with holes, they have to use here in the local space the same parent as our wall with holes. So this is the wall with windows. And for the handles here, because they link to the windows, so they need first here for this one the local space, the same local space as our window here. So this is here window 1. And also for this one here, uses as object link this window, so the parent object is the windows 2. So, and now we can rotate it around, move it around, and of course scale it around. Okay, here in the last example, I like to show you how to build this wobbling stone circle here. So I have here already 5 stones here. I have them from Capsule. So what we like to do first is like to stack those stones on top of each other, and at the end we use a bend deformer to build a circle. So here we have those 5 stones. Let's bring them into an cloner, and then on the cloner we like to have a linear. Maybe remove here a bit of the spacing, so actually it doesn't matter how much spacing we have, and then let's decide how many stones we like to have. We say 15, and maybe also use a random distribution here. First we give the stones a little bit of rotation, so let's use a time effector. Then say here, I think this is already the right direction. Okay, they rotate, and let's give it a random field. So random mode. So now they rotate with individual speed. Next, we like to have different scales of those stones. So let's add a random, say here, random initial scale. Activate scale and give them kind of some random scale here, something like this, doesn't matter. And mode is random, that's fine. And then we like to add another random effector to give them some animation scale here. So also go to scale and put here in some random numbers. I think this one is a bit too harsh here. So yeah, actually it doesn't matter. You can play around with those settings as you like. So, and then I think we go here to noise. Say maybe speed of 20. You set this to UV. I think here in the Y, let's add some more scaling here. Yeah, okay, something like this. So now we like to stack those stones one on top of another. So we can't do this here with our normal capsule, so we have to bring here our setup inside of Nodes. So first what we like to do is connect the cloner here, so deactivate weld now. So we have here a single geometry, and then we like to use an Nodes Modifier here, and then we call this maybe stack stones, then open it here, put it down here, or maybe to here, it's better, so we see it a bit better here. So first thing we like to do, we need, because here our geometry here, it's just like one big geometry. We have to split the geometry into different geometries. So we can use an explode mesh islands. So now we have here an array here with geometry. So maybe let's use a get element. So, and now here we can see we have the individual stones. I'll go back to 0. And now for our setup, maybe let's go here to the side view here. Let me explain what we have to do. So this is our first stone here. So we need a match size operation for when we use the doodle here. This here maybe is our stone with the index 0. Then our second stone is around here, with the index 1, and the other one with the index 2 is around here. So we have to stack them one after each other. So we have to first to bring the first one to here. So this is one. And then we have to collect them. So we have both here with the index 0 and the index 1. And then we have to bring the second one, the third stone to here. Like this. And then also connect the stuff and so on. And then the one with 3 will be around here and so on. Okay. So what we have to do is here our first stone. We already have here our first stone, so we need the other ones. So we can use an erase element from, so here we have all stones. Oops. So we have to erase the index, so the first one with a count of 1. So we have now here is our first stone, and here is an array with the other stones. And now, because we have to do this stacking operation with one stone after each other, we can do this with a loop carried value. So here is the loop carried value, and here we have our initial value here. Initial value is a geometry object, so the first stone here. So this is the first stone, and then we have to iterate here over our other stones here. So iterate collection, and then we have to bring in each stone here into our loop, and the loop here we close this with the curly bracket. So for every stone we have one loop cycle. Then let's jump inside the loop carried value, and here we can start our stacking operation. So we use the match size now for this. Use the match size node here, and then we have to first switch it here from match to classic object to geo input. So now it uses here this geo input. So we like to match here the second stone here to our first stone here when we think of the first loop cycle here. And first we like to connect them. Let's connect here the matched stone here with our initial stone. Bring this here to the output, maybe connect this to here, and now we see we have here all our stones back. But now we have to decide here our match operation. So this is pretty simple. We just like to match it in the Y direction. So activate the Y and not center to center. So we actually like to match the minimum to the maximum. And now all the stones are on top of each other. So sometimes we have some little gaps here, so we can maybe make a little offset of -1. So bring them a bit together. Maybe also let's make a parameter here. Bring this outside of the loop carried value, and let's make an input. And now we have here on our stack stone modifier here, we have the offset, so we can decide it here as parameter, maybe 2. I think -1 is fine. Okay, that's it here inside of Nodes. So let's jump back to our standard layout here. Now we have all the stones, and now when we press play here, you can see it is pretty slow. That's because we have a lot of geometry here. So for a preview, we can make this much faster by taking here, take all our stones here and bring them, maybe deactivate everything first. Let's have a look on the mesh, and now let's bring them into an poly reduction. And maybe a reduction of, or maybe something like this. Then activate everything again. Now you can see it is much faster now. Okay, now next thing I have to do, it has to stay always at the same Y scale. So let's build a box. Maybe let's use a display tag here. Say just, oops, here just lines. And then the box here, the X scaling doesn't matter here. And maybe say here the Y 200, that's fine. And then bring here the cube also to the bottom here of the Y direction here, so we can use an axis, geometry axis for this, or also a match size, so doesn't matter. Then let's match the Y here, say the minimum to center, and now the box is here, perfect. And then after the stacking, we use also here also another match size. And with this match size, we scale our pile of stone here to the box. So used here the cube. And then the scaling here, and let's say not uniform, and just in the Y direction. And we also have to center it in the Y direction, so center. Now it always matches the size here of our cube. And then the last thing we have to do is to use a bentiformer. So bring the bentiformer here to the cube to fit it to the parent. So we have already the right size. Then move it up 100 and then bring it here to the bottom of our connect. And then let's keep the length here. And then rotate it 360 degrees. Maybe let's hide the bentiformer. Let's press play. And you can see they move around now. So, and now we can say, okay, let's make some more stones, maybe 5 here, something like this. Yeah. And the last thing you like to do is to rotate our circle, so it because here it stays always fixed. So let's make a null, bring this to here, and then here the center of our circle is around here. And then of course we could rotate it here, but now we have a problem. That's again because we are in world space here and we try to rotate it. So let's go to the match size here, say local, and then we like to bring it here to the connect, and now it stays here perfect. And then of course we can animate here our axis, but we can also use, first let's bring it to the center here, and we can also use here in Cinema 2025 the new field drivers. So let's go here to B and say field drivers, add field driver. Then go to the field driver and maybe say from 0 to 180. And then inside the field, we use a time field. And then say, okay, 180 degree in around 10 seconds. So 250 frames. Then let's press play. And it starts to rotate. Yeah. And then at the end, of course, when you like to render it, just go into the cloner and deactivate here all the poly reduction. Then you have the final stones back. And now, of course, it is a bit slower, but for rendering, I think this is no problem. And that's it for this example. And in the next one, we do a little nodes exercise. We build a little world bounding box modifier. Okay, so this is what we like to build here. We like to build this global bounding box capsule here. So when we move the torus or rotate it here, or move it around, it always builds this global bounding box cage around the torus. Okay, then let's make a new file. Let's make a torus, then add a Nodes Modifier here. Just type in Nodes, then Nodes Modifier, then jump inside of Nodes. Maybe let's go to the side view here and bring the geometry here to the output. And what we need first is the bounding box information. So we use a bounding box node. Then here we have the minimum bound, the maximum bound, and the center. So when we subtract first switch it here to vector, subtract the minimum from the maximum, then we have here the dimensions of our bounding box here from the torus. So we can use now a cube and add those dimensions here to the size of the cube. Then use a connect. Then connect our torus together with the cube. Then this to the output. And now we see here, we have now a cube around our torus. So, but we like to have it as kind of a cage. So let's use an edge to line. So now we have, whoops, the cube here to the edge to line. And now we have here splines for every edge. Then we use a sweep. Whoops. Then plug in the edge to line to our path here. And then for the profile, we use an end side. Add this to the profile, maybe the end side here, radius to 1. Then add this here to our connect. And now we see we have here this little bounding box cage. So, but now when we start to rotate here our torus, we see the bounding box follows the rotation. So that's not what we want. And that's because we are working here, when we work here inside the Nodes Modifier, we're working inside the local space of the torus, not inside the global space here of our world. So let me explain. Let's go to the side view. So when we think of our world axis, we have an XZ plane. Let's use a doodle tool. We have our XZ plane is here. And when we rotate the torus, like 30 degrees, then the bounding box should actually look like this. So when we think of this, we have here the XZ plane of our world coordinate system, and our torus has an, let's use another color. The XZ plane of our torus in local space is around here. So we need to rotate here our torus. When we go back to green, when we think this is here our torus, this is like rotated 30 degrees to our world XZ plane. We need to rotate our torus also in the local space. So this is the XZ plane of the local space. So it looks something like this. So we need to rotate it here. So this we can do with the global object matrix here. So the global object matrix are those coordinates. So actually the global coordinates of our torus. So we have to re-rotate our torus here first. So we can do this with a transform geometry. So now we pre-transform here the torus geometry with the global object matrix, then plug this into the bounding box. And you already see here, we have now the bounding box is now the same as here our green bounding box, just rotated. So that looks correct. But what we have to do now is to bring our bounding box here back to the global space here, so that it matches here the green bounding box. So we can do this with a node called inverse matrix. So this is kind of the opposite of our global object matrix. And when we use this here after the sweep line, so we use again transform geometry, and then we use the inverse matrix, plug this in here, and now we can see our bounding box matches here our global bounding box that we defined here. But now we have one problem. So maybe let's hide the doodle. When we move the torus, we see the bounding box stays always here in the center. That's because we also move our geometry first. So we moved it here with the transform, and then we moved it back here to the center. So we need a solution to move the bounding box back here to the center of our torus. So here in the bounding box node, you have here our center. So we can use this to add this position here to our inverse matrix. So we can use a transform matrices here, and then add here the inverse matrix, and also here the center to the second matrix here to the translation, and then plug this in here. And now our bounding box moves to the center of our torus. And now we can move our torus around. So, and our bounding box stays always there where the torus is. And also it doesn't matter here when we move the pivot or rotate the pivot, it always matches. Also scaling works. So yeah, so that's it for this little exercise. And I think we are now at the end of the video. So I hope you like it. If you have any questions or you find a bug inside the match size capsule, just write it to the comments. And then I wish you a happy day and we hear us in the next tutorial. Bye bye.